We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann Parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live-to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick-pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
The Sporlan division of Parker Hannifin Corporation is sponsoring this podcast. Sporlan is the leading manufacturer of HVAC&R components. Using quality materials and craftsmanship, Sporlan maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max, Press to Connect, and Zoom Lock Push, Push to Connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporlan.com.
I guess that's Jim and John for Sporlan signing off.
Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're here with your hosts, Brett Wetzel and Kevin Compass. Are you at home?
Yeah, I'm at home this week.
Actually, someone that works here asked me today if you were going to Albuquerque. Are you still going out there?
I don't know. It keeps getting pushed back and pushed back and pushed back. Because every time I go there, it's not ready or it's worse off than when the last time we left.
Are you still doing cutovers, or what are you doing this week? Service work?
No, I'm doing cleanup and playing hot potato, and I am. What was that? Sorry, my daughter's screaming in the background.
I can't even hear it.
Yeah. And then I'm doing a bunch of walkthroughs for gas conversions for 404, 507 to 448.
Yeah. I'm in California this week. We're restructuring some of the construction stuff. So literally it looked, you ever see that meme of Charlie Day from It's Always Sunny, where basically he has a whole bunch of stuff up and he's trying to pinpoint everything? Yeah, that's what we had going on.
Fuck. You what?
Yeah. Hey brother, I gotta take this. Fuck. Yeah, so tonight we're gonna get started on, since Kevin's doing the 404, 507 to HFO, we're gonna get started with talking about that and how to prep for it. And well, no, are we doing prepping, or are we just gonna roll through it?
We'll do both. We'll roll through it.
All right. Well, you want to start off by basically telling where you start off?
Yeah. All right, guys. With doing this kind of work, like retrofits in general. Everything is in the prep work. Being like super detailed on your scope, what the customer expects of you, reading over what their scope is, and then having your own kind of internal scope too, what you're going to do and how you're going to go about this and what your expectations are and how you're going to do this. Now, I do a thorough site walk. Usually I'll spend a day and a half there just going through everything in the store, trying to find no stone left unturned. I'll go through everything like we did in the previous episode. Like I'm getting in cases, under cases. I'm trying to find any ball valves anywhere, any solenoids anywhere, anything that's hidden. So I want to go through and try to find all the hidden stuff. So as we're going through this, we're going to try to find everything that's hidden. So I'm going to go through and I'm going to look through logbooks. I'm going to trace out piping. I'm going to try to find all the little nooks and crannies where things get shoved. Then I'm going to start going through each rack individually. And I'm going to start making out lists of everything that needs changed. Now, when you're going from 404 to 507 to 448 or 449, you're not going to have that leak potential like you would from 22 for the ball valves specifically, because you don't have that chlorine in there. Now, since that chlorine's not in there, you're not going to have that leak potential. With that being said, stuff still leaks. It does. And if it's my own thought process and everything else. Like if you're doing one of these jobs and you're taking the gas out and you're doing a gas changeover, everything's already there. The fitters are already on site. Just change the high side ball valves. For what it's going to cost to change the high side ball valves, you're eliminating leak potentials and you're eliminating ball valves that probably don't hold. If the rack is older than 10 years old, let's be honest, those ball valves probably don't hold all the way. So why not just eliminate that right away? It's going to be more cost up front, a little more cost up front. But I'll tell you what, to do 2 or 3 ball valves here, 2 or 3 ball valves there, it's going to be way more expensive than just to do them all in one shot. So I'm a big proponent of getting those ball valves out. If they're leaking at all, if there's any signs of them leaking, then I'm going to go through and I'm going to gut them all. And all the high side ball valves are coming out. At a bare minimum, the drop leg and discharge ball valves are getting changed. I am going to go ahead.
No, I was going to say, don't you typically, I mean, it should be bid out when you're doing that, because even people, there's a misconception where they're oh, it's POE oil, you don't have to change anything over because you're going from POE to POE. But from the experience I've seen, like if they don't at least try to attempt to put some kind of retrofit ball valve caps on there, they end up leaking like a damn sieve.
Yeah, it's been 50-50. I've seen them where they leak and when they don't leak. Now, I hate those retrofit ball valve caps. Like, I'd rather just replace ball valves. But those retrofit ball valve caps always leak. As soon as the rack shuts off, they start pissing refrigerant. Power outage, pissing refrigerant.
See, I've seen it both ways. So I'm because it has like basically 3 seals, right? You have the 2 rubbers that are on the shaft, where the retrofit portion goes into the new ball valve cap, and then you have the Teflon at the bottom. And then I like putting a little Loctite 515 on there, which is a gasket eliminator, so it doesn't rock hard like a conventional like leak lock, which I despise. I think anyone that uses that shouldn't use it because it ends up causing me to strip things out, and I just don't dig it.
Yeah, no. So those retrofit ball valve caps, and I don't know, they seem like when they cool down, especially if they're on discharge lines or if they're on like a drop leg, as soon as they cool off, they start leaking like a sieve. So me personally, I'd rather just change the damn ball valve out. Then we don't got to deal with the ball valve bleeding through. We don't got to deal with it leaking later. I'd rather just change the ball valve. So all the high side ball valves, I would like to get changed out.
Gotcha. And have you seen anything? Do you recommend also changing out the suction? Have you seen it leaking out through there? Because I've seen the same.
If they're shot, they're getting changed. If they're old, if they're 4 bolts, if they're crappy, cruddy looking, they're getting changed. But like most of the time, I don't see suction ball valves leak. I've seen 20-year-old ball valves 30-year-old ball valves not leak.
Did you? So those ball valves, like, are you the one that's doing the actual walkthrough where you're taking the count, or are you relying on someone else to do the walkthrough?
No, I'm taking the count.
Okay, so that's one thing you guys have to remember, right? So what Kevin's doing is a lot different, but typically when you're doing a gas conversion, you're not the one who actually walked the store, right? So a lot of times you didn't change the ball valves, so there has to be some communication made. If you're already seeing them leaking at all, you need to make that call to a manager and be like, hey, listen, we have to do something different because it's going to be a bitch trying to pull a vacuum in the later date, right?
Well, yeah, everything, pulling a vacuum, dealing with other stuff. That I rather just change the high side ball valves out. Like the suction ball valves, they get neglected a lot of times because let's be honest, it's probably going to cost double to change the suction ball valves. They're twice the size, and they're always a bitch, especially if they're EPRs above them. You're talking a lot more cost.
And you're still changing out all the gaskets on like the holdback A9. No.
So the last two jobs I walked, they didn't want any paper gaskets changed out. So nothing paper is getting changed out. They're doing less with these 448 to 507 retrofits than they are the R22s. So if it's got paper gaskets, it's not getting touched. Like discharge check valves, they're not touching them. I'm rebuilding the discharge check valves and drop like check valves with their 4 bolts. It's not on the scope, but it makes my life a lot easier and it's one less leak potential. So that's one thing I'm focusing on. Shoot, there it was. You're muted.
So you're not changing any of the gaskets and any of the EPRs, sort valves, anything like that? You're just letting that ride?
Correct. Nothing gets touched on any of the EPRs.
Gotcha.
So I hardly ever see sort valves leak, even on the R22 to 506 or R22 to like 448. Like you hardly ever see EPR leaks. They're generally liquid ball valves and discharge ball valves. So anything when you're doing these retrofits, it's going to be a pain for a service guy to change. Generally, we're hitting.
Because it's going to leak up later. I really don't want to deal with that, but yeah. I'm sorry, I kept muting myself because my air conditioning in here is loud. It sounds like a jet engine.
Yeah, so anything it's going to be like hard, I mean, to change. So like anything it's going to be like difficult. Like we already got like there's 2 guys on site that could pull a valve out. If it's a 3-inch valve, a 2 1/8 valve in a bad spot where there's already 2 fitters there with rig torches, it's going to be a lot easier. So we just need that's my philosophy with it. If it's going to be a bitch to change out later on, you might as well just do it now. While you already got guys up there that are pipe fitters. But then start going through the oil system. Okay, now's the time to upgrade oil separators. Switch to a undersized centrifugal or a filtered separator. So getting that filtered separator in there is going to help you a lot. Your oil should not really be that bad. You're going from 404 or 507. You have gas that, is a fairly good low temp refrigerant. It's already POE oil. I mean, you shouldn't have the dirty aspect from going from 22 to one of these gases.
Not just that, but you have more BTUs per pound versus 448 and 449 versus 404 and 507, right? Because typically even the nozzles and stuff are a lot bigger on 404 systems because there's less BTUs per pound. So you need more refrigerant in order to do the same amount of work. Sometimes what you can see once this thing is started up with the 448 and 449, a lot of times in some evaporators, depending on how big the nozzle is, you could potentially see lazy liquid feed where it basically just comes out of the distributor, but then like follows the path of least resistance, doesn't really get doesn't get spread evenly out. and then essentially causes what I refer to as lazy liquid feed, where you'll end up seeing the valve will clamp down because it's getting a lot of copious amounts of flow from the bottom passes, but then towards the top you don't have an even frost pattern. So you could literally draw a diagonal from the top pass all the way down to the end where it comes out the suction. Like you'll see that portion of the coil is not actually getting the same superheat as what the bottom is. And I know we talked about this before, but Kevin, we talked about putting a suction temperature sensor on each pass to actually see if you have even superheat. If you do suspect that from happening, if you do see it out there.
Yeah. You should not really going to have the dirty aspect. I take every chance I can to clean this up when we're doing it. So like we're going to do an oil change. It's not like a R22 store with mineral oil where we're going to have to do multiple oil changes. Generally, it's just one oil change. You're just getting the oil freshened up with the new gas. So what I will generally do is I'll just do a quick oil change each compressor. I'll drain it down. I'll pump the compressor out. I'll clean the oil strainers. And I will clean the oil strainers, clean the centronic switch. I will make sure that everything in the compressor is flushed out. I'll clean the screen in the compressor, clean the float, make sure it's all clean. Get all the trash out of the bottom of the compressor. Get it all nice and ready to go for this refrigerant that's going in there. Now, once it's started back up, I'll fill it up with some fresh POE oil. I'll get the reservoir filled up with fresh POE oil. Get that thing flushed out. Change the oil filters before the changeover. Let it run while we're doing the ball valves and everything else. And then in that same time, we're taking that and we're generally, most of these stores have been converting all the pressure controls from ones with capillary tubes on them, armor cap tubes, to encapsulated. So
just trying to reduce the amount of leak potential that you have.
Correct. They're wanting to get rid of the cap tubes to get rid of leak potential.
All right. So you have a customer that's actually speccing that out. So you'll have those rules before you go to spec the job, so you know what to expect, right?
Correct. You're going to have all those, what they're going to expect. But if you're doing leak reduction stuff and you're trying to walk a customer, site, and they leave it up to you, installing those encapsulated controls, that's an easy way to do leak reduction. Cap tubes leaking, flares leaking, that's all one more thing to leak. So getting rid of it and just putting it on the compressor and making sure that there's no T's on there, nothing that's going to crack. So that's one thing. But it all depends on what the customer wants, what their expectations are with that. Now, as we're moving on, as we're doing this gas changeover, we're getting all the ball valves put in first. We're getting the compressors taken care of, getting the oil cleaned up. And then something just fell. I'm assuming my daughter threw something down the stairs. As you're doing this, you're getting everything cleaned up. And then I leave the store side to the end. So you got shraders to do. You do not have to do shraders. On everybody's spec, it's been if they're leaking or not. Me personally, I do the shraders, especially all the shraders in the rack. It's cheap insurance. It doesn't take that long. You could have 2 apprentices knock out a rack or 2 a day. Just go through a core pullers and just change all the shraders. Put caps on, paint them blue, so that way that cap's been changed and everything's good. Generally, I will Ziploc baggie everything, and I will tie it to whatever it's on. So if it's a EPR to get rebuilt, Ziploc baggie with the old parts to it. Same thing if it's like a holdback valve that got rebuilt, Ziploc baggie with the parts to it. So that way, if you got a bunch of guys on site, we could look at it and that valve's been rebuilt and you could see who rebuilt it. I generally will make people initial it. So if they fucked up, I know who fucked up. So, I mean, that's one thing. But as you're going through this, you're going to see the biggest thing. And if a customer doesn't have it in their scope, you need to push it, is changing all the power heads. Because in the beginning, I think it was Target was doing this. They were just leaving the power heads.
Yeah, and then basically, they thought by throttling it down, you were going to be able to settle it. But the problem is because I've seen this happen firsthand, where the superheat will swing from 2 all the way up to 18, and you can actually see the swing in the actual in the discharge air temperature. That's how severe it is. And yeah, so change them out. And actually now, like I know they used to do 448, 449. I'm sorry, R22 power heads, but now they actually have a power head. I think the charge is a D charge.
For what?
For 440 for HFOs for 448 and 449.
Really? I was
Yeah,
told I was told it was the same as the VC charge. They were just changing it.
I'll tell you in 1 second, but I'm like 99.9% positive. Go ahead, continue. Sorry.
So getting the power heads done is like key. Like I've been a part of having to set superheats afterwards, and it sucks ass having to have the 404 power heads on there. It's just it hunts all over the place. It doesn't maintain superheat well. Lots of flood back, lots of problems. So you're going to want to avoid that. So doing the power heads. Now, this is where it gets tricky because if you do the power heads before, you got to open the valves up. Okay, you have to open the valves up because you're gonna have 448 suction pressure in there, or I'm sorry, 507 or 404 suction pressure, and there's a closing force, and you're gonna have an opening force that's way less on that R22 bulb. So you're gonna have to open the valves up, maintain the case temperatures and superheat. So generally, it's like a turn and a half, 2 turns. Now, when you go to do this gas changeover, you got to shut those valves back down because you're going to be wide open because that valve porting is sized for 404, which needs way more mass flow. 448 does not. So you're going to have that problem. So I generally, the way we've been doing them is we do the power heads before. Some customers want it done the night of. That is way too damn stressful for me, and it causes way too much time. If you got to change 100+ power heads, that is a lot of time. By the time you get a vacuum rolling, you're talking like 5-6 hours.
Even if you got a couple of guys, it's still, because at that point you still have product in every single case, right?
Now you're at the bottoms of the cases, and it's just, you're not going to get it done in 2.5 hours, which is when the product's going to be done. It's not going to happen. I don't care if you had 15 guys there. You couldn't manage it. You couldn't efficiently manage it. Even if there was 2 guys per lineup doing them, you still, if you wound up with Hussman cases, I mean, you got one every 4 foot.
That's a shit ton of power heads.
Yeah, you're talking 100+ power heads.
So I have a question for you. So what do you recommend? Because I've heard it both ways. If you have Hussman coils that obviously have non-adjustable expansion valves, do you get the retrofit kit to make those adjustable?
Nope, cut them out. Q bodies.
That's what I was just about to ask you. What is your preference?
Q bodies with strainers. I'm not even going to waste the time. They're getting cut out. But by the time you unscrew the bottom and you put the adjustment stem on there, the thing's been running for 10 years with a strainer that's half plugged.
It's already warm.
It's already warm. So screw it. It's getting Q bodies. And by the time you go through and waste the time with that, you could have a fitter could have already burned in 3 of them. By the time you go through and do it, and then say one leaks, you got to pump it back down. I would rather just cut the dryer out of the case, hard pipe the dryer, and leave the strainers in there because I'd much rather clean a strainer than cut a dryer out.
100%. I never understood that. Like, I understand like a dryer is made for moisture removal, and also filtering, but why do you put a filter before a filter? I don't understand that.
Like at the rack?
No, I'm talking about like why do you put a filter dryer before the TXV if the TXV has a strainer?
I don't know. I hate it.
Well, and so do I. That's what I'm trying to understand. I don't understand why they even remotely do that.
I don't know. I here's my thought process on it. All the OEMs do it. Like Zero Zone throws a dryer in their case. Husband throws a dryer in their case. Phoenix throws a dryer in their case. Let's just be honest. 90% of guys don't purge. There's really shitty install practices going on.
What do you mean?
there's shit service practices going on. So what are all these manufacturers trying to do? They're trying to keep that warranty call from coming in from that valve not feeding and getting misdiagnosed and the warranty for that valve. That's all they care about. They just care about that warranty not coming back for that valve or that case having an issue. That's it.
You know what I haven't seen for a very long time? An expansion valve that's legitimately just frozen up because of moisture in the system.
We have a store. Actually, it's getting shut down today.
What?
Yeah. It's one of those Walmart stores that got shut down.
Gotcha.
It had a moisture problem, like really, really bad. Underground piping had a small leak, and it had a habit of burning out the suction transducer. So the home office would force it on, and it would run into a vacuum, and it would suck water. And then you would spend all this time getting the moisture out with dryers, and then you would just get random service calls. It was awesome. Like, I don't know, getting this free overtime because you just go there and just dump a bucket of water on the valve and it would just take off. You're
That's
muted.
awful. That's awful.
Yeah, I mean that's the only store I've ever seen moisture in a valve freeze it up. And it was a SanWow case or SanWow or Sanyo.
Sanyo? Yeah,
Sanyo.
I think Sanwa is the valves, right? Those are the valve manufacturer that Kaiser uses. Sanyo cases. They look almost. I think they have a back wall coil.
Some TVs.
I think so.
TV.
I want a TV in my fridge.
I don't think they don't make refrigerated cases anymore. I know that. Because
Panasonic technically does, right? Well, I'm Panasonic owns Husband, so technically they do.
I guess. Wait a minute. I'm having a brain fart.
About what?
We got
Sanyo cases?
Today's episode is sponsored by the RefraShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Oh, we got so far off track. Damn you. Back to the retrofits. So getting the power heads, like, you want to get them done before. I'm a big proponent of doing them before. It's too stressful having that many people mess with that many power heads. You're just asking for a leak, and you're pulling vacuums. Let's be honest, you're not getting down to 500 a retrofit. Like, you don't have time for that. I mean, unless they're pulling all the food, you're gonna want to just get that thing. The night of the retrofit, I don't want to do anything besides pull the gas out, slam new liquid cores in there, and pull a vacuum, and then recharge it. That's it. I'm not doing anything else unless we have some ball valve that, like, we astronomically can't change. But, like, we're doing condenser ball valves before. We're doing all the ball valves before because we could pump this thing down as many times as we want, do 2-hour stints and just knock it out. I don't want to do anything the night of the retrofit. I don't want this 2 a.m. scramble, panic attack. Like, that's not good.
So in your instances, do you always use dry ice?
Yeah, I mean, it depends.
Okay. No, I was just curious because some people will try to cheat the system. I've had a lot of luck just with service pump downs where, like, basically you take a conventional rack, open up the EPRs 100%, put on the compressors 100%, let those coils get as cold and as frosty as humanly possible, just to give you a little bit more longevity with the product, as well as you have some ice on the coil, which makes your pump down a hell of a lot longer. Doing that and putting dry ice in the cases, I've actually had a rack down for I think 6.5 hours, and temps just finally hitting their alarm set point.
Yeah,
So-
it really depends. I'll usually come in an hour before and do exactly that. I'll drive all the temps down and get everything
Helps
rolling.
get a little bit longer out of your shutdown time, right? So you're not having to beat the clock, so to speak.
I don't give a shit what anybody says. That food is warm no matter what.
No,
Yes, it is. Yes, it is.
it's not.
It is too. whatever magic they're saying, that food is warm. Unless you're at like a Costco or something where they have like redundancy. They literally pull all the cases. So if you're doing a rack, they pull all the cases on anything that's on a rack. They pull all the walk-ins have another rack in there. So it's running at 50%. Same thing, you go do the next rack. It's running at 50%. They pull all the cases on that, move it into the walk-ins. So those are less stressful because you have the time.
Plus, you have a big ass box that you can throw a bunch of shit in too.
Well, yeah. If
There's so many POSs that you can just basically fill up, right?
Well, yeah, and like those box stores, even like Sam's, everything's in boxes. It's a lot easier for them to pull cases than it is for like an entire store to take everything out of the cases and out of the pushers and everything else. There's no pushers. They're all in cardboard boxes they cut in half. So it's a lot easier. But you also have a lot more gas to deal with.
Very true.
Getting the power heads done before. I'm a big proponent of getting the power heads done before and then going back and setting superheats. Like usually what we'll do is somebody will do the changeover at night and I'll usually come in I'll let one of my guys do it at night and I'll come in the next morning and I will start running through superheats. I'll usually get there like 4 a.m. Those guys should be charged and running. I'm taking over. I get the rack smoothed out and then with a good charge in it. And then I'm going to start going to set superheats. I can do probably an island an hour or a row of cases an hour, sometimes more. I'm doing like 10, 12 valves at the same time. So I'll run through these fast. So I'm not really worried about having to go through. But like generally the night of the changeover while it's pulling a vacuum, I'll have those guys go in there and then run all the valves back in 2 turns. So that way we're not flooding out when they start putting all this refrigerant in there. So the next big thing before you do the changeover is you need to check with the compressor manufacturer to make sure A, you're going to have enough horsepower and capacity, which you should. B, you're going to need liquid injection. So whether it's Carlisle compressors getting Y1037 valves, Bitzer compressors are getting BMTs installed, or Y1037 valves, Copeland compressors are getting demand cooling installed. You need to check and see what you need. Okay. You need to look at if you're going to be in that design where you're going to need the demand cooling. So you're going to need that. So you're going to need to install a liquid header. You're going to need to install or liquid stop valves. You need them with Carlisle or Bitzer. Whenever the compressor's on, the liquid stop valve needs to be on. However it's set up. If you're using like the BMT, which is Bitzer's version of demand cooling, you don't need the liquid stop valve. It is a pulse valve type liquid stop valve. So you're going to have that. But you're going to need some sort of liquid injection for this compressor. You're going to need it. So you're going to have to order all those specific parts. So you're going to have to figure out for every single compressor. Like today, I had like 7 different types of Bitzer compressors. I had to go through and order. It's a different kit for every single compressor. So you got
you talking about the actual pulsing one or doing the 1037?
the pulsing one.
Okay.
What that costs.
Yeah, because like all that sizing shit is based off of a couple different factors. Typically, it's sized off the horsepower of the compressor, the saturated suction temperature, as well as the suction returning temperature. And I know we've talked about this where I've had an instance where the engineers designed it for a 35-degree superheat coming back to the compressors, and they were only like a 1/3 ton valve. But with the way the suction was running in a certain store, I had like 55 degrees of superheat. So in turn, I needed a bigger valve. So you have to be mindful when you're sizing those up to make sure that you're doing it correctly.
Generally, from what I've seen for most supermarket applications, a 3rd ton valve for the Y10s is usually pretty good. But like you said, you got to check. But like generally on anything smaller than like a 15 horse, which is generally what we see, it seems to be a 3rd ton valve is sufficient. I like to go with the 190s though. I don't go with the 210s or like the 240s. I go with the 190s. They're going to inject more, and it's going to inject more, but it's going to cool the discharge temps down. And I'd rather not cook the oil. So I think it's a trade-off there. So I'm going to go with that. But you need to have this done before. And then the next thing is head cooling fans. You're generally going to have head cooling fans. So you need to look at every compressor envelope, like all these ones I've looked at, whether they're Copeland, Bitz, or Carlisle, they were all in that range where they needed a head cooling fan. And to be honest, if I'm going from if it's low temp, if I'm going from 404 or 507 to low temp 448, 449, it's getting a head cooling fan. I don't care if the OEM is a requirement, it's getting a head cooling fan. So why not? Head cooling fans are cheap. It's cheap insurance. It keeps the compressor cool. I'd rather not cook the oil. But generally, you're going to need head cooling fans. You don't need them on medium temp, but on low temp, you're going to need head cooling fans. Yeah, anything you want to add to that?
No. Oh, yeah, I do. When you're talking about the Y1037 valves, or even if you have a temperature sensor on the discharge line, basically checking your discharge temperature, if they're not doing enough internal temperature, if you do not have that sensor wrapped, you will think that you have a bad 1037 valve, because I've done it. And I never did it again. I installed these valves at a store. We were ripping out the scrolls, Copelands, and putting in Bitzers because that's just what the customer wanted. I sized these valves up, and I was like, well, what did I do? Did I mess it up? And I did not read all of the directions. I read most of them, and it says wrap the sensor. And I'm like, no, there's no way that head cooling fan is moving that much air away. Yeah, bullshit. Oh, yeah. No, it did.
That bit me in the ass too one time. These things are all fucked up. Every one of them.
Dude, I pulled out one twice. The straight, because they don't have a secondary. You don't have an external serviceable strainer, right? They just have the inline one. So I re-insulated it, pulled it, unbrazed it back out, and I'm like, there's nothing in there. And I shoved it back in. And okay, and I did it again, and all of a sudden, wasn't feeding again. I'm like, what the hell? I was really close to pulling it out again, and then I realized I didn't have the bulb wrapped, and that's when I was thinking to myself, no, there's no way that's going to cause it. No, it will. It moves a shit ton of air away from that compressor. So make sure you have everything wrapped, insulated, and strapped properly with either like a TXV bulb strap, or I'll even go for a hose clamp. Just don't crush the bitch.
TXV bulb strap work good. I have been using stainless zip ties. I bought a stainless zip tie gun on Amazon, and I've been using those to tie sensors onto stuff. Works out real nice. Not a fan of hose clamps because they come loose and they rub.
Because of the vibration?
Because the vibration causes the screw to loosen up, and it rubs. I've had to fix 2 leaks now, and the fucking hose clamp rubbed through because they used a stainless hose clamp, which is the nice hose clamp, but stainless versus copper, copper's going first. So if you use a shitty like aluminum hose clamp, the aluminum's going to go before the copper. But if you're going to test these Y10 valves too, like Brett said, heat gun works pretty good. So if you're going to test them, like to see, make sure they feed. You're not going to obviously be able to see what temp they feed without it being on the line of the compressor. But if you want to test them to see if they do feed, heat gun. Just heat them up with a heat gun and grab the outlet, make sure it's feeding. These Bitzer BMT modules, I'll give you guys some how you want to do it. I don't really know. They're kind of a pain to mount because they're made to be panel mounted. So in a retrofit application, they're kind of a nightmare. I was looking at it today, and anywhere I put it inside this rack panel and the door, it's going to close against the board or a breaker, or because they're like 5.5 inches long.
Is it like comparable to the size of like a replaceable Dick Cell controller, like one of the universals, like that long?
It's wider and longer. It's like 5
Oh,
long out the back. So it becomes a problem panel mounting these. If they're doing it from the OEM, like it's fine because they put them all in a row and they leave a spot there. But when you're retrofitting this, it becomes a problem because you got to drill a 2.5-inch hole in the panel. That's what they want for like you to fit this in there, and there's this front plate that goes across it, so it's massive. So you got to put 4 of them in. You need like almost 1.5 feet of space, and then you have to deal with, is it going to close? So before you start drilling holes in the panel, take this from experience, make sure the panel's going to close and you aren't going to hit anything, because you look at the depth, you're like, oh yeah, it'll be fine. It's plenty deep enough. But then you're like, shit, it's hitting a breaker, or now it's hitting the back of a board. Or you'd be like, in my case, somebody put one in and shut up a door and the wire just arced to the board.
lame.
So,
Well, that's so I know like on the new compressors, like you can get a Bitzer compressor that has like digital unloading as well as that same module, because it has pressure transducers and temperature sensors all hooked up to it, except for it's the SEI module. I think that basically does everything for that compressor. They didn't go to that yet.
so is the CME module, I think.
CME, okay.
Those things are the cat's ass.
You have, so just so you're aware, in order to hook up to it and program it, you need the Bitzer Very Speed adapter kit, which lets you talk to the what?
It's Bluetooth.
What?
Yeah, it's Bluetooth. You can do it off your phone.
The new ones are?
Yeah.
Some bitch.
So I've only seen them on digitals. I have never seen them on anything but a digital. I think they're kind of just saving that for right now until they get enough of them, but it does everything. It does your head cooling fan control. It does your liquid injection. It does everything. So you basically, pipe it in, easy wire it. It's all the safeties are there.
No, I was going to say there's also pressure transducers on there, and I forget what they're for. I think for the digital unloading, so it can modulate that based off the suction pressure. So you could actually have it on like a single system and digitally control that compressor.
I don't know if it can do that. I'm sure
Yes.
it could.
No, it can, because I just remembered at the thing in Cali, I went to one of the Bitzer classes because I just wanted to know more, and they were talking about it because the guy was saying, oh yeah, you can put pressure transducers on there, and I'm like, well, what for? Because typically you're sending it just a signal from the BMS systems, but in this instance you can put a pressure transducer on the suction and on the discharge and basically cut it off if it's too high. It can shut it off in case like the compression ratio gets too crazy. So there's a lot of like cool little nuances that you can do with that controller.
Yeah, I've never seen it with the pressure transducers. I just see them in the bare bones with the digital unloading. But when you get those out, like if you come out and they're on a startup, you need to program them. They're not pre-programmed. The OEMs, I've never seen one program one yet, so just be aware of that. It's super easy. You just got to tell it how many unloaders it has. But that's part of these retrofits. Like I'm trying to add the digital compressors in. Like I always sell that as an upcharge. So I'm trying to get the customer to do it because you're going to have capacity issues. So why not just do it when it's cheap and that's the thing I like about the Bitzers is they'll let you unload both heads. On a Copeland, you can't do that because of the way the oil's set up from the oil pump, the passages. That's one advantage you get with that. Like you can unload both heads. Variable speed is obviously king now, but the digital unloading, that CME module is loads better than the Bitzer's old digital unloading, which was like super laggy.
Well, are you talking about the module that was the Siemens module that basically took the analog output signal? Is that the one you're talking about?
Which would unload at like 10 volts and sort of unload at 5 volts and kind of.
Yeah, but the problem that we had is a lot of times the card that's in there would come out.
Yes.
So that's one of the problems, right? And then it wouldn't work. It would go red, and then you'd have to basically unplug the card, put it back in, and then power cycle it to get it to work. So that's one of the things. They've now fixed that down to like a like an actual SD card rather than the little plug thing. So you have to make sure whenever you're replacing that module, that whatever compressor that module was intended for, that it's the module that you are. Because like if you put in like a fucking 3 or a 4-cylinder compressor versus like a 6, it's going to want to pulse differently.
Yeah, it was definitely something to compete with. It was not a competition for the IDCM. Like this, those
It worked.
It worked. It's like that onloader that lasted for like 6 weeks.
I hate you. You're such a dick. So everyone hears, me poke a little fun, but what Kevin does is says shit and whatever else, and then I have to edit it later.
Brent has to edit it out.
Just letting you know, sometimes I'm tired when I'm editing. So,
whatever. It won't be the first time I got a phone call about something I said on the podcast. It definitely won't be the last. So, anything like that, guys, you're trying to add on to these retrofits. If you're going to do these, if you're trying to upsell a digital compressor, I mean, it's going to make it go so much smoother. But regardless, that doesn't need to be done for the retrofit. Just doing the gas changeover itself and following what we laid out here, getting the liquid injection put in, getting ball valves that look like they're leaking or are going to leak changed out, solenoid valves that are leaking changed out. You don't have to change them, but if they're leaking, get them out of there and get them rebuilt. And then just going through everything and make sure if you're finding hoses that are leaking, just get rid of them. Big proponent. I am no longer using the armored cap tubes. I switched over to reflex hoses.
Wait, what? Since when? Which one of the reflex hoses?
They're like the gray hoses, like Hill's been sending out and stuff.
Really?
So those reflex hoses, you could buy a kit and make your own hoses.
Come on.
It's a crimper. It's super simple. It's a crimper, and you could buy whatever you want. You could buy 3/8 hoses, 1/2-inch hoses, 1/4-inch hoses. What is it? Like whatever that, I think it's DN2 hoses, which is what all the.
Is it like a mechanical fit? No, because you're saying crimping. So is there rubber gaskets involved?
No. So it's basically making a hydraulic hose, but like you're crimping it yourself. You put the end on it. Like they're solid. They're pretty hard to fuck up.
No, I'm cool with that. I thought you were gonna say it's some kind of rubber gasket type thing. Okay.
But they're crimped hoses. Like that's what Costco specs now. So they spec you can only use reflex hoses. So what's nice about them is you can make custom hoses. So if you need a 48-inch hose, you're not putting cap tubes together or something like that. You're just building whatever hose you need and cutting it and putting the ends on and crimping it. If you need 2 straights, you can make 2 straights. If you need 2 90s, you can make 2 90s. If you need one side to be 3/8 and one side to be 1/4, you could do that. So you can make your own custom hoses. And once you buy the kit, it's not expensive. You're making hoses for a lot less than everything else is.
How much is a kit?
I'm not sure.
It's not that expensive. I'm not sure how much it is.
It's not my money. It gets billed to a job. I know it's cheaper than buying like an entire like 30 pack of armored cap tubes.
What did you call that again?
It's reflex hoses. No, don't ask me to spell things.
No, I'm just gonna do it just to be a dick. Reflex math.
You're such an asshole.
Can you spell that, please?
Yeah, I'll send you the link for them later.
Oh,
but
okay. I think it's reflex with 2 F's.
Yeah, they're really nice. Like you can get color coded ones.
Yeah, I see that. As Kevin would say, it's the cat's ass.
I hate you.
I know. It's all right. You get over it. I'm just getting even with me having to do more editing.
Yeah, whatever. Let's say something else, but I refrain from it.
All right. All right. Reflex hose is awesome. All right. Max working pressure. Ooh, 80 bar.
So yeah.
Yeah. Interesting.
I honestly, I think every service van should have a kit with those on it.
Dude, the burst pressure for, I don't know what the difference between the DN5 and the DN2 is, but it's 700 bar and 500 bar. Holy freaking poop.
Yeah, me personally, I think every service truck should have one of these kits on it.
100 degrees Celsius, Kev.
Yeah.
So you can use this on discharge and suction in, because it's rated all the way down to negative 40 degrees Celsius.
Me personally, I think this should be on every service truck, because okay, you got to get armored cap tubes, you got to get a cap tube. You can make whatever hose you want with this.
Your hose.
I mean, it's a small initial investment. Then you're not buying armored cap tubes because those things suck.
Well, then you don't really have to worry about having to caulk it up and stuff, right? Because then
Eat that shit.
What?
When they're caulking up armored cap tubes,
I'm just saying, like, then you don't have that extra length. You can figure out essentially what the correct length is going to be. That's really cool. I didn't even know you could do that.
Yeah, I mean they're super simple to make. Even have one at the shop, and if you had to make them up and send it back out the next day, if you're making custom hoses, especially if you're doing a lot of gas changeovers, that's how you save money right there.
So tell your service manager that Kevin told you that you have to have it, right?
Yeah, it goes on a job. But other than that, guys, I mean, doing a 448 to 404, 404, 507 to 448, it's no different than doing a normal retrofit, just with less leaks. You're going to have to change less stuff, but you're not going to have that R22 leaks. You're not going to have that mineral oil problems. So you're just going to have a lot more. Make sure the superheats are set on the cases. Make sure you're not flooding out. More of a problem of flooding out than anything. Making sure you're not overfeeding on stuff. Making sure you got enough oil in there. You're not washing out the rack. So that's the biggest thing. But just doing that preliminary work and making sure that everything is scoped out, and going to doing the retrofit is no different than doing the actual R22 retrofit. Same guidelines, just you're going to have a little bit less work. So we're going to wrap it up for tonight.
Cool. All right, guys. Well, listen, thanks for listening again, and have a great night.